Good day, our dear panelists. I am here to present our final defense about design, fabrication, and testing of a zero point 0.5 kilowatts wind-powered water purifier and filtration machine. Next slide, please. So to begin with, I will present chapter 1. Next slide, please. So for the overview of the background, life on Earth exists because of water. It is no secret that 96.5% of the Earth's surface is composed of various bodies of water, which makes the planet habitable environment for different species. The Philippines faces water population and sanitation issues with 52% of the population lacking access to potable water. Proper filtration is necessary in areas experiencing these issues. This study focuses on designing, fabricating, and testing a water purifier and filtration machine powered by wind energy. Next slide, please. So wind power is rapidly expanding renewable source. It is cost effective and efficient. Wind turbines convert kinetic energy into electrical energy to generate electricity. Next slide, please. So for the statement of the problem, the problem the researchers want to tackle is the coastal areas that are surrounded by water that still needs work of having stocks for recreational water. Most coastal areas lacks access to application for purified and filtered water. And also solar energy relies heavily on sunshine and it's only applicable when it's daytime. Next slide, please. So for the objective of the study, so the first objective to design a zero point 0.5 kilowatt vertical wind turbine that can generate steady electricity in various wind speed and integrate an existing filtration and purification system in the Philippine market capable of treating in recreational water class 1 in accordance to the Philippine National Code 2017. We will also fabricate and integrate a wind turbine and existing water filtration and water purification system in the Philippine market to function as a single unit utilizing eco-friendly materials in fabrication process of the wind turbine. And lastly, conducting a test to evaluate the power generation of the wind turbine and evaluating effectiveness of the water treatment system in achieving the recreational class 1 in accordance to the Philippine National Code of Drinking Water 2017. Next slide, please. So for the significance of the study, this research lies in its applicability in solving the insufficient supply of the recreational water class 1 in coastal areas. This study focuses on the concept of harvesting wind energy to vertical wind turbine, then converting it to mechanical energy or electrical energy to power the pump, then proceed with the filtration and purification of the water into recreational class 1, class B. Next slide, please. So for the scope and limitations, the power generation test will be utilized to test the generated electricity in watts. The wind turbine will generate electricity to power the pumps as a renewable energy source. We'll be utilizing two centrifugal pumps. The one will serve as the suction to gather the water, and the next one is the pressure booster to treat the pressurized filtered water to reverse osmosis to achieve the recreational water class 1. The sample water will also be submitted to an accredited laboratory for testing. So overall, this study is to generate electricity using wind turbine used to generated electricity to power the pumps and test the water that comes out of it. Next slide, please. The significant limitation is that the prototype testing will be conducted offshore in Batangas, and the researcher will not consider the other energy sources, processes of clean of to clean the water, areas that are insufficient in wind energy, and beneficiaries for treated water.
Now, chapter 2, the review of related literature. So, the review of related literatures, which are the studies or literatures that is utilized as a basis to make the study credible. So, it acts as the cornerstone of the study, which new information is built so that the researchers can uncover research gaps, improve their research questions, and have a true comprehension of the body of knowledge by looking earlier studies. So, here are some of the studies which are the main basis of our study. So the first one is the water-operated water purifier by Joshi et al. 2019, which is a study to design and develop a fully functional wind-operated water purifier, where wind utilizes as a windmill a reciprocating pump, and a reverse osmosis purifying component. So the next study is development of wind-powered water pump by Odessola and Adinoye 2017, which is a study to construct a wind power irrigation water pump. And lastly, the optimization of wind power desalination and pump hydro storage system by Segurado et al. 2016. So the study provides a strong support for the group's chosen topic because it covers the key points such as using wind energy to generate alternative power for desalination device for the water in order to minimize the likely cost of the electrical power that will be used to run the device at a cheaper cost and to ensure that a reliable source is used in the operation. So you can browse here in the next slides the other studies which have been utilized as a basis of our research.
For Chapter 3, Theoretical Consideration, which will be considered 3.1 wind turbine, 3.2 motor, 3.3 water filtration, 3.4 is water purification, 3.5 is pump, and 3.6 is wind map. For the wind turbine, a wind turbine is a multi-body complex system that includes blades, a wind wheel, a drivetrain, a generator, a nozzle, a tower, and other components. The natural frequency decreases gradually as wind turbines evolve larger and lighter. As a result, there are several complex calculations and formulas essential to knowing how to construct wind turbine generators. The formula used is P is equals to 1/2 density times area times velocity cube. Next is the Betz limit. According to the Betz law, the maximum efficiency of a turbine is 59.3%, considering that the wind speed would be zero when the turbine turned all of the energy from the wind's motion. Its usable energy provides straightforward explanation of the law. Next is the motor. A motor is a device that converts electrical energy into a mechanical energy. A motor is a device that converts electrical energy to mechanical. Most motors work through the combination of motor magnetic field and electrical current produce force in the manner of torque supplied in the motor shop. In desalination process, the function of a motor is to employ the pumps in the whole process because in the reverse osmosis system, it requires a high pressure to be maintained throughout the process. Next is the water filtration. The implementation of a water filtration system is a crucial measure in ensuring that both communities and individual households have continuous access to clean water that is free from contaminants and associated health hazards. A ceramic water filter, commonly referred to as a CWF, is a filtration device that for the purification of water. It is composed of a blend clay and sieve combustible substance. The CWF or ceramic water filter is known for its high efficiency. It's a prominent household water treatment system that finds application in many contexts such as rural areas and emergency scenarios resulting from natural calamities. Next is water purification, technique of removing contaminants and poison from water by reverse osmosis, sometimes referred to as reverse osmosis water purification, is a well-established and widely employed process. The process operates based on principle of facilitating the passage of water molecules through a specialized semi-permeable membrane in a selective manner, while concurrently obstructing the passage of larger particles and dissolved chemicals. The process effectively eliminates a diverse range of contaminants including minerals, salts, heavy metals, bacteria, viruses, and an organic compound, so yielding potable water that is highly purified and devoid of any potential hazard. Next is the pump. The study will make use of two pumps to suction and increase pressure. Seawater will be pumped into the filtration process. The water accumulated in the water container will be pumped to increase the pressure which enters reverse osmosis. The pump must be reliable, efficient, and compatible with the relevant regulation standards and local codes. The equation involved are located below. Next is the wind map. Figure 3.1 shows that wind energy that can be accumulated in the Philippines. According to National Renewable Energy Laboratory or NREL, the Philippines has a total wind capacity of 76,000 megawatts. And also, figure 3.1 categorizes black, which has the highest wind electric potential in megawatts, while white has the lowest. For the chosen location for this study is Batangas, which is shown in figure 3.2. For figure 3.3 shows that it can be classified as producing excellent wind power in rural areas. Batangas has a wind electric potential ranging from 500 to 1,000 megawatts. Also, it shows that the wind around the area of light blue region produces wind speed of 6.4 to 7 meter per second, which is sufficient for the required capacity of the proposed prototype for this study. Next is stored energy. A flexible way to store the extra power generated by wind turbines is through battery storage devices. These systems are excellent for capturing surplus energy and storing it later. Integrating batteries with wind turbine offers versatility and adaptability, making it a viable option for commercial and residential energy needs. Battery storage is considered the optimal solution of maximizing of use and wind energy because of its adaptability, making it suitable for optimizing self-consumption, providing backup power, and managing peak demand.
For Chapter 4, the methodology. Next slide, please. The methodology has three processes: designing, fabricating, and testing. Under the three processes are different stages. Next slide, please. The summarized matrix outlines the methodology. The design process begins with information gathering, followed by determining components, design and calculations, and 3D modeling using software like Fusion 360. Research settings include online and physical libraries, utilizing materials such as books, journals, and published studies. Data for prototype computation parameters can be sourced online, accessible via personal computers and mobile devices. The fabrication process involves costing and purchasing materials, designing and calculating, selecting a wind turbine and pump, and assembling the prototype. Research settings for this stage include hardware stores, online retailers, and the researcher's residence, requiring a variety of materials and manufacturing tools. Data gathering is conducted by canvassing different stores for material information, again using personal computers and mobile devices for online access. Finally, the testing process includes power generation test, pressure testing, and water testing. A water testing and a prototype test run with conclusions and recommendations drawn from the results. Testing will occur in selected areas around Batangas and in a water laboratory for a water testing. Required materials include voltmeters and ammeters for power generation test, pressure gauges for pressure testing, and the fabricated prototype for the test run. Data will be collected by monitoring and recording the outcomes using equipment such as chart recorders and guidelines from the Philippine Clean Water Act of 2024. Next slide, please. The information gathering includes brainstorming within the group and knowing that what needs to be executed when doing this study, such as a test run of the whole setup. Next slide, please. This is the visual diagram prototype setup with components. As you can see, we have a wind turbine connected to the two pumps. For the pump to work, we need electrical energy generated from the mechanical energy of the wind turbine. The suction pump will get seawater and then move it to the filtration. And filtered water comes out and then will be pushed by the second pump through reverse osmosis to purify it. Next slide, please. Before creating a 3D model of the prototype, researchers will calculate various parameters essential for the design of a vertical axis wind turbine. This includes measurements related to the turbine's capacity and performance. Swept area of the turbine is equal to 3.2562 square meter. The wind power is equal to 1.992 kilowatts. The turbine efficiency is equal to 25.817%. The power output is equals to 0.514 kilowatts. The torque is equal to 14.60 Newton meter. Next slide, please. The researchers will calculate a pump's volume flow rate, hydraulic power, and brake power using the formulas and the pump's specifications. The volume flow rate is equal to 0.00167 cubic meters per second. The hydraulic power is equal to 370.51 watts. And the brake power is equal to 673.655 watts. Next slide, please. This is the 3D model component of the wind turbine. The wind turbine design is based on the H. Darius turbine, which is a vertical turbine. Next slide, please. This is the filtration and purification 3D model component. Next slide, please. This is the last component that was designed, the centrifugal pump. Next slide, please. This is the final prototype setup. Next slide, please. For the costing and purchasing of materials, the success of this endeavor hinges not only on the innovation of design, but also on the reasonable allocation of resources. Appendix D contains the comprehensive breakdown of material cost and serves as the guiding beacon in navigating the financial landscape of this project. Next slide, please. In the selection of wind turbines, the researchers compared the vertical and horizontal axis wind turbines. The researchers chose the former. Next slide, please. Selecting the right pump is essential for designing an effective reverse osmosis, purification, and filtration system. The pump must generate sufficient pressure to overcome osmotic pressure, ensuring efficient water flow to the membrane for freshwater production. It should be capable of managing system pressure variations to protect sensitive RO membranes, which helps reduce maintenance costs and extends the system's lifespan. A recent study highlighted the selection of a 24 DC centrifugal water pump connected to a battery via an AC to DC converter, designed for an approximate power output of 0.5 kilowatts. This choice reflects the need for reliability and efficiency in RO system. Next slide, please. In assembling the prototype, researchers will begin by fabricating the wind turbine using purchased materials and specified measurements for each component, including the turbine's height, blade size, and the length of the steel rod connecting the wind blades to the bearing that facilitates rotation. Once the turbine is constructed, an electrical wire will be connected to it to transfer the electricity generated during operation. This wire will link the turbine to the pump, which will create the necessary pressure to move water throughout the entire system. The assembly will incorporate a pipe system that connects the pump, filtration, and purification components, establishing a flow from the starting point to the end point. Initially, a suction pipe will be attached to a pump with a motor, directing seawater through the filtration system. Following the filtration, the seawater will pass through another pump into the purification system. Finally, treated water will be collected in a container with a discharge pipe, facilitating the release of the purified water. Detailed assembly instruction can be found in Appendix F. Next slide, please. The researchers will use a voltmeter and an ammeter for the power generation test to test the generated electricity in watts. Next slide, please. Water pressure testing is crucial in plumbing to assess the reliability and performance of water systems, ensuring they can withstand operational pressures without leaking or breaking. It helps detect leaks, verify component functionality, and prevent future damage, ultimately ensuring the plumbing system can safely operate under pressure. Complying with defined standards increases the longevity and performance of the system. Next slide, please. Next slide, please. The information produced by certified labs is essential for its use as data for water testing. Next slide, please. The researchers will do a prototype test run for the fabricated machine to ensure the functionality of the prototype and gather the data needed for the study to improve it further. Next slide, please. The researcher will synthesize the results from the testing of the water and test runs of the machine. Furthermore, the researchers can generate conclusions about the results from different parameters. Moreover, the researchers will also look for room for improvements to help future researchers to enhance the machine. That would be all for Chapter 4.
Chapter 5, result and discussion for purified water, pressure testing, and power testing. Purified water. The purified water subjected to 9 tests, namely free chlorine, color, nitrate, lead, arsenic, cadmium, pH level, total dissolved solids, and turbidity. These tests adhere to maximum allowable level or MAL specified by the Philippine National Code for Drinking Water of 2017. According to the result, the parameters of submitted water should not exceed MAL for each category. The output water passed 8 out of 10 laboratory tests. However, its pH level reached 8.11, exceeding the acceptable range of 6.5 to 8.5 pH level. This indicates that the water could become more bitter in taste. This is the parameters for the water testing provided by the Philippine National Code for Drinking Water in 2017. Next is pressure testing. Researchers installed the water pressure gauge between the pipes to measure the pressure when the water flows through the system. A pressure relief valve was also installed near the pressure gauge to control the limit of the water pressure within the pipes. This valve discharges fluid when the pressure exceeds the system maximum, causing a pressure drop to maintain an optimal pressure level during operation. The working pressure of the water at the test run was 38 psi, and the maximum pressure that the reverse osmosis, 5-stage reverse osmosis water filtration is 50 to 60 psi during operation.
Now, for power testing, as the turbine generates power to charge the battery, various measurements were recorded at different intervals. First, after 30 minutes of operation, the turbine produced 50 volts, 3 amperes, and 150 watts. Then after 1 hour, the turbine output was 48 volts, 2.5 amperes, and 120 watts. Then finally, after 2 hours of operation, the turbine generated 24 volts, 2 amperes, and 48 watts.
For Chapter 6, the conclusion and recommendation. Next slide, please. For the conclusion, the study involves the design and fabrication of a wind turbine that powers a water filtration and purification system. Its dimensions, including height, diameter, and the blade sides are optimized for charging a 24 volts lithium-ion battery, which is essential for the system's operation. The assembled prototype demonstrates a well thought out design that effectively combines renewable energy generation with water filtration and purification. The turbine is constructed using scrap metals, and pipes, promoting sustainability and reducing cost. The turbine's connection to a generator, electrical lines, and a rectifier ensures that wind energy is efficiently converted into electrical energy, which is then stored in a battery for future use. The water system includes a centrifugal pump, a ceramic water filter, a 5-stage reverse osmosis system, ensuring high-quality purification of seawater. The system is enhanced with foot valve, pressure gauges, and ball valve for improved reliability and efficiency. Next slide, please. The turbine's energy generation is influenced by wind speed, but the battery storage system provides consistent power to the pumps, even during low wind conditions. The automatic control system, which incorporates pressure switches, optimizes pump operation, conserving energy by shutting off when not needed. Laboratory testing conducted by Aqualab Center in Quezon City confirms that the treated water meets drinking water standards, exceeding the study's objective for recreational water. The system maintains a working pressure of 38 psi, well within the operational limits of the filtration components, ensuring effective purification and system longevity. The integration of the wind turbine and water purification system addresses energy and water insufficiency issues while enhancing environmental sustainability. The prototype demonstrates significant potential for real-world applications, especially in remote areas, by providing reliable access to clean water and efficient energy management. Next slide, please.
So for the recommendations, future researchers can embark in this study by elevating the location and capture so they can capture stronger wind and more stable wind speed. So the size and the blades are also crucial in determining how much wind the turbine collects. Also, lighter rim can enhance the rotation efficiency, while heavier rim can hinder its performance. Well-built foundation is vital in ensuring the stability and durability of the turbine. The site selection is another important consideration for future turbine research. Next slide, please. So by choosing the sites with more stable wind speeds, they can enhance the operational effectiveness of the wind turbine. So moving on to the filter, we utilize a 5-stage filter, and we can recommend that adding another filter membrane such as ultraviolet filters can significantly enhance the water quality by eliminating the bacteria and balancing the pH levels. So considering uh, the use of portable hoses instead of durable pipes can also improve the turbine research. So lastly, employing a long-lasting battery for energy storage is essential in maintaining reliable power supply for the wind water purifiers. So these are the references that are used uh, to integrate this research.
So Appendix A, the Gantt chart. Next slide. So the Gantt chart shows the actions done and the timeline of our study. Next. So Appendix D are matrix of related literatures. Next. Matrix of related literature is the summary of the studies used as the basis in the study which is discussed in the chapter 2.
For the Appendix C is the matrix of methodology. This is the methodology summary I discussed earlier in chapter 4. Next slide, please.
Appendix D, which is the material costing. The researchers provide a list of materials that is used for fabricating the prototype, which has a total of 339.8 pesos. Next is Appendix E, calculation of pumps and wind turbine. This shows the calculation that is shown in chapter 4, which is the calculation of the wind turbine and pump.
So Appendix F is the assembly of the prototype. So as you can see, these are the following materials that was used in the process of building the research. So these are the prototype dimensions, as you can see. And Appendix G is the laboratory result for water testing, which was tested at Aqualab Center in Quezon City, which is further discussed in chapter 5. So to all the panelists, thank you for taking your time in listening to our final defense.